Yeah, so we had done up to the pizza kind of the project, I can say, in terms of CNN, where we worked mostly with the TensorFlow. So some of the cases we had done with to extract the data from the different levels. We also done some data loading part at the time, and we can also visualize much more better what are the different images we had. So let's also tune this. What are the different models we had to be work around? So we have seen some hidden layers, right, at the time. So if you take this consideration, we have taken some of the hidden layers to encounter to depends on the CNN mechanisms, whatever the hidden layers we had, along with the operations called padding and striding. So this operations will be helpful to do any kind of the matrix to do kind of this steeringness, or you can say stridingness, at the time of you are converting with some input images to output images. So some of the hidden layers we're going to be encountered at the time. If you are I mean, if you are remember those things, that is very helpful in this class. So becoming of some of the creating some other models, then we can also evaluate these models. So you can download from this link actually, so that you will get to know this pizza and the steak data sets we are going with together. So this is the data, I can say this is the data we had in the zip file with regarding the steak and also the pizza. We need to classify whether it is a pizza or the steak with compared to the whatever the images we had. So pre-processing steps, we already seen some of the pre-processing steps yesterday, I guess, and these are the some pre-processing steps we can also see much more in detail way. And this is a rescaling of the data. Whenever we had some of the RGB colored image, just we have to rescaling of the data with respect to whatever the number access with respect to the color we had. So we already seen white holding the 255 and the black, a dark black is holding for the zero right at the time. So that's very rescaling of the data for each and every image with corresponding to the train and test images what we had. The storing into the train data and also the test data to represent the different target sizes. Currently we are using 224 cross 224. So this is the output image we are going to be get at the end. Along with the class mode is a binary, because since it is we are just classifying with the pizza and the steak, right? And also something called as a batch size. So batch size is nothing but whenever you providing any batch size is equal to 32 or the 64 128, at a time we are just passing these batch size to our training of the model. So 32 images will going to be passed at a time, and another 32 images going to be passed at a time, another 32 images going to be passed at a time. So by training the model, you don't require to do any kind of you can say truncating kind of the thing. So at the time you will be passed the raw images or the bunch of the images that may be hang out some of the cases. So for that reason we use the batch size, mini batch size, to do not any hangout of the results while doing the training data sets. So even the unseen data points we may be in come across less than of the 100 or maybe the thousands, okay, but may not be that much of bigger sizes. So for test data also we can take that consideration for the batch size as for now. Yeah, we have 15,000 1500 images on the training data sets, and for the test data set we have the 500 images. So let's also focus more on the some of the data preparation processing what we just encountered yesterday. So while training with the data you require to do what are the different labels we had. So we have the images along with the labels, right? So on top of that we have the images. This is a pizza, it's going to be give as a pizza label kind of the thing. If it is a stick, it's going to be give as a stick kind of the thing. So we have labels according to that. So what will happen if the labels are not there at the time of your training the data? You need to get this label by using the clustering mechanisms. So we already discussed, right? Clustering mechanisms are very helpful at the time of we don't have any label data sets. So clustering will going to be grouped together with respect to the pizzas for the pizzas data sets, pizzas images, you can say, along with stick images what we had with some of the similarity matrices, I can say. It consists of some recognitions of their edge. So many edge will maybe recognize their edges with corresponding to the pizzas will be so similar, and also the stick will be similar. It will be separated by each and every cluster at the time you take in two cluster or two means. So we already learned k-means algorithm. If you're going to be take consideration k is equal to 2 means cluster is going to be very helpful for separating the pizza and the steak. At the time you eventually get these bunch of the points, or these bunch of the images consist of the steak, this bunch of the images consist of the pizza, then you can label it. Once you labeled it, then what will happen, you can train your model according to whatever we learning currently. So few of the cases it may not be possible to get the label data. For that you have to do the clustering mechanisms to get the label data for every task, not only the classical ML, not only the deep learning, or maybe the NLP related tasks, or computer vision, and even the time series analysis also. Some of the cases time series may not be works out, and few of the cases will be works out. That depends on the data itself. So yeah, so these are the some of the images we had with respect to rescaling of the data images. And if I go down, yeah, you can see we just